In our previous lesson, we saw the basic structure of a C program by writing and executing a simple program to print hello world on screen. But printing hello world on screen is not doing something very meaningful. In a typical task that we would like to perform using a computer program, we will have some data and then we will have to perform some operations on these data. Let's try to understand this through an example. Let's say we want to perform this task of calculating simple interest. The data that we will work upon will be principal amount, which will be a positive number. It can be a real number because it can have fractional part. Rate of interest, once again, it can be a real number because it can have fractional part. Time in years will be a positive integer. To calculate the interest, we will have to perform 2 multiplication operations and 1 division operation. We will have to use this formula. Even if we want to perform all this computation manually, we will have to collect and store all this data somewhere. If the data is not too complex, we can store it in our own head, in our own memory. Else we will have to write it down on a piece of paper. Now when we will perform an operation on data, new value will be created or some previous value will be modified. Once again, all of this has to be stored either in our own memory or on a piece of paper. Now if we will try to solve such a problem using a computer program, first of all the data that we want to work upon should go to computer's memory. And if some operation is performed, newly created data once again has to be inserted, modified or updated in computer's memory. So we must have ways in our program to store, access and modify data in computer's memory. If you look at this expression here, P into R into T upon 100, P, R and T here are variables. Variables by general definition are things that can change. In this expression, P, R and T can be anything. 100 in denominator is a constant. A constant is something that won't change. 100 is 100 in any part of the world. We have concept of constants and variables in programming also. You can think of constants as values of different types that you can write directly in your code, in your program. An integer, a real number, a character, or a sequence of characters that we call a string in programming. Names, words, phrases and sentences. In a program, all of these are strings. If we use values for these different types directly in our code, then we call them constants. There are defined set of rules to create constants of different types, and sometimes a constant can also have a name or identifier. I will talk about these concepts in a while. We can think of a variable as a unique name or identifier for a section of computer's memory where we can fill in some data. So if P and Q are 2 variables in my program, you can imagine them in the memory like how I'm showing here. P is only a name for this section of the memory, and using the identifier P in our program, we can store some data here in this section of the memory. Basically, we can read and write to this section of the memory. Similarly, Q is another variable that is identifier for this part of the memory. Once again, using the identifier Q, we can read and write to this part of the memory. In programming, quite often we use this term identifier for name. That's why I'm saying identifier a lot of times. Once again, to create and work with variables, we have to follow the rules of language. Constants and variables in a program are means to store and represent data. Now, data can be of various types. Different types of data are represented differently. We saw some of the types while writing these constants. Data can be a number, sometimes an integer, sometimes a real number. Data can be a word, phrase or sentence, and then there can be all kinds of complex forms of data. And the kind of operations that you perform on different types is different. Moreover, any data that has to be stored in computer's memory has to be binary, has to be a pattern of ones and zeros. Any data from the real world first has to be encoded or converted to binary, and then it can be stored in computer's memory. So there will be different encoding mechanisms for different types of data. We will talk about this in detail later. For now, just understand that different types of data are stored differently in computer's memory. A constant or variable in a program must be of a defined data type. A programming language gives us definition for some basic data types that we call primitive types, and then the language gives us tools to create complex types or composite types using primitive types. So primitive types are already defined in the language, and composite types need to be defined by us. In our initial lessons, we will mostly be talking about and working with primitive types. Most famous primitive data types are int for integer, char for character, float for real number, and there is another one for real numbers. It's called double. Int, char, float, double, all of these are keywords. Keywords are reserved words that are always used in a program for a specific purpose with a specific meaning. So these keywords will always be used to mark the data type of something. There are some other primitive types in C. We will talk about them later. There is one more building block that we need to know about, and then we can go ahead and write some programs to perform some real computations. We must know about operators. Constants and variables are means to store and represent data. Operators specify what to do with data, what operation to perform with data. I will list down some of the operators. Operators are also of different types. We have arithmetic operators, plus minus for addition and subtraction, asterisk for multiplication, backslash for division, and percentile sign for modulus operation. These are arithmetic operators. A single equal to sign is called assignment operator. It is used to assign value to a variable. And we have operators that we call relational and logical operators. Two equal to signs is for equality operator. If you want to compare two values for equality, you use two equal to signs, and this is a logical operator. And then we have operators like less than, greater than, less than or equal to, greater than or equal to. These operators are called relational and logical operators. We will get to know these operators when we will use them in a real program. Constants, variables, and operators are combined together to create mathematical and logical expressions that would evaluate to something. For example, let's assume that p and q are variables of type integer, then p plus q will evaluate to the sum of values stored in p and q. P plus 2 will evaluate to the value stored in p plus 2. Now 2 is a constant here. 2 is a constant of type integer, and we can have complex expressions also, like this one to calculate simple interest. Let's now see how we can use these building blocks in a real program. I will start where I had left. This is the program to print hello world that we had written earlier. As we had discussed, a C program is organized in entities that we call functions. We must always have a function named main in our program. Program execution always starts with first statement in main function. There are some functions that are pre-implemented and available to us in what we call language libraries. To use those functions, we need to reference the language library to which they belong. This statement here, hash include stdio.h, is referencing the library stdio.h. Printf function that we are using here is part of this library. The first line that I have written here is a comment in my program. Comment in a program is text that is ignored by the compiler. It is not considered for execution. You write a comment in a program for things like mentioning the name of author of the program, or for describing problem statement, or for explaining some part of your code, all in natural language. There are two ways to write comment. If you write something starting two forward slashes, then everything starting the slashes till the end of that line is a comment in your program. You can begin a comment after a C statement also. Another way to write a comment is start with a forward slash and then put an asterisk sign, and then everything after that is a comment unless you close the comment with another asterisk sign and then a forward slash. In closure, asterisks would come first. Using this method, you can write a comment in multiple lines. Okay, so what I'm going to do now is I'm going to write a comment using constants and variables. So we are going to learn how to create constants and variables in a program. I'm going to leave this printf statement as it is for now. To use a variable in a program, we first need to declare it. To declare a variable, you write a statement like datatype space variable name. A C statement must always end with a semicolon. This statement is a variable declaration. We have declared an integer variable, a variable of type integer named a. Basically what we have done is we have reserved some space in the memory to store an integer, and we can read and write to this memory using this variable name or identifier a. To fill in some value in this memory or this variable, and we can fill in all the integer because this is a variable of type integer, we can write a statement like a equal some constant and a semicolon to end the statement. Filling in some data initially in a variable is called initializing the variable. This statement a equal 12 is an initialization. We can declare and initialize a variable in same statement. Instead of writing these two statements, we can write a single statement like int a equal 12. So we are declaring as well as initializing here. 12 is an integer constant here. As we had seen, constants of different types are written differently. This hello world here is also a constant. It is a constant of type string. String is not a primitive data type, it's a composite data type. String is a sequence of characters. Character is a primitive data type. A string constant is always written as a sequence of characters within double quotes. This string constant is being passed to printf function as argument. When we pass something to a function, we call it an argument to the function. And a function can take more than one argument. It can take arguments. What I'm going to do is I'm going to change this string constant. I'm going to write a equal %d. So I'm putting this percent sign here and then d. And now I'm going to pass one more argument to this function, variable a. How many arguments a function will take and what all arguments it will take depends upon the definition of the function. Printf can take one or more arguments. The first argument must always be a string constant. If I will put a %d somewhere in this string constant, then printf will expect another argument of type integer, and we can pass either a constant or a variable of type integer. Now when printf will print this string, it will replace this %d with the value of this integer. Things will be clear if I will run this program. Upon running the program, this is the output that I'm getting. Printf is printing the string, but it has replaced %d with value in variable a. This is called printing a formatted string using printf. If we only want to print the value in a and nothing else, we can get rid of this part. And now we are printing only the value in a. Printf is a magical function. It can do a lot of wonderful things. We will see all of that later. For now, this printf statement is printing the value in integer variable. Okay, so we are declaring and initializing an integer variable and then printing the value in that integer variable. Let's now create some more variables of other types. I want to create a character variable, so I will type in data type char and then I need to type in a name. I cannot use the variable name a again. Two variables within same function cannot have same names. And when I say same names, small a and capital A are different. You can have a variable name as capital A and it's fine. Now I can initialize my character variable with a character constant. A character constant is written as a character within single quotes. To print value in character variable, instead of writing %d, write %c and then pass the variable c as another argument. Printf will now print the character for you. Now I want to create a variable of type float, so I will be able to store a real number. Name of a variable doesn't always have to be a single character. It can be a set of characters. The rule to create a variable name is that you should start with a letter and then you can have letters, numeric digits, and one more possible character, underscore. Ideally, a variable name should be something meaningful from real world. And there is one more rule: your variable name should not be a reserved keyword in C. Keywords are supposed to be used for specific purpose in a program. Like break is a keyword, so you cannot have a variable named break. I will name this variable real underscore number. There can be no space in a variable name, so the underscore character can help bridge two words. We can initialize this variable with a constant of type float, and to print the value in this variable we need to say %f, and then we need to give the name of the variable as second argument. When I'm running this, as you can see, this real number is getting printed. Okay, so with this much we understand how to store basic primitive data in variables. In our next lesson we will see how we can take data as input from user of the program. Right now we are filling in all the data from within the program. We will also solve problems involving simple arithmetic. In our previous lesson we saw how we can declare and initialize variables of different types to store data to be used in our program, and we also saw how we can use printf function to print data stored in a variable. Now in this lesson we will see how we can take data as input from user of the program, and we already know of printf that can be used to print output, but we will talk about printing output in a little more detail. In this program that I'm showing you here, I'm not doing something very meaningful. What I'm doing is I'm declaring a variable named a of type int, which is basically reserving some space in computer's memory to store an integer, and we can access or refer to this memory location with name a. And then we are filling in value 12 in this variable. In memory, the value will actually be present in binary. In my logical representation of memory, I would always show data the way it's understood in real world, but we must remember that any kind of data is encoded and stored in binary. Different data types are encoded differently, but ultimately in memory everything would be in binary. We will discuss encoding mechanism for different data types in later lessons. Coming back to this program, as I was saying, we are not doing something very meaningful here by declaring and initializing a variable and then printing the value in it. We are not solving a problem here. With whatever we have learned so far, let's write a simple program to solve a real problem. I want to write a program to find product of two numbers, or rather product of two integers. I have erased everything from inside the main function here, and now I'll write code to find and print product of two numbers. I'll first write a statement to declare three variables of type int named a, b, and c. We can declare multiple variables in same statement. We should first write the data type, then space, and then variable names separated by commas. And of course we should have a semicolon at end of the statement. I am also showing these variables in memory here. Now I have written two statements to fill in values in a and b. I am filling in 12 in a and 14 in b. And now with this statement c equal a asterisk b, what I'm doing is I'm calculating product of values stored in a and b. Asterisk is symbol for multiplication operator, and we are filling in the product of a and b in c. And now we can print value in c using printf. Printf function, if you remember this from previous lesson, is used to print a formatted string. First argument to printf function should be a string constant or string literal. A string constant is created by putting a sequence of characters within double quotes. String constant that we have passed to printf function here has two characters, % and d. Now what printf function basically does is it prints the string constant, but it may not print the string constant as it is. Before printing, it applies a set of rules and does some formatting. When printf would see a %d in the string constant, it would expect another argument of type integer corresponding to this %d, and it would replace %d with value of this integer. So what should be the output of this printf statement that I've written here? Well, in the string constant we only have a %d. This %d will be replaced by value in c, and value in C is 168, so 168 will be printed on screen. I'll just put a return 0 in end here, and now if I'll run this program, then this is what I'm getting. Now in my printf here, if I would pass something like product equal %d as first argument, and once again for the %d I'm passing C as second argument, then output of this particular printf would be product equal 168. Only the %d has been replaced with value in C, and everything else is same. Everything else in the string constant is printed as it is. Now I want to write my printf statement like this, and I want you to guess the output of this printf. What do you think should be the output of this printf? Now we have 3% in the string constant, and in total we are passing 4 arguments to printf. Apart from the string constant, we are passing 3 integers, one corresponding to each %d. While formatting, printf will replace this first %d with value in A. So first %d will be replaced by first argument after the string constant, and then this second %d will be replaced by value in second argument, that is value in B, and the third %d will be replaced by value in C. If I'll run my program, this is how my output will look like. Okay, so we have a program here that's calculating product of two numbers, A and B, but we are setting the values of A and B in code itself. Of course, I can change the code if I want different values for A and B, but ideally, my program, while it's executing, should ask the user to input A and B. Now what I'll do here is I'll first erase these two lines where I'm setting values of A and B. I'll keep everything else. And now after the declaration, I'll make a call to a special function in stdio.h library. stdio.h is already included here. And this function is named scanf. There are two arguments to scanf. First argument, just like printf, is a string constant, and it should not be very difficult to guess that we are passing some format here. And second argument is variable A preceded by an ampersand sign. I'll talk about why I'm putting an ampersand before A in some time. What I'll do now is I'll write one more scanf statement here, and this time the second argument is ampersand B. Now I want to run this program and show you what will happen. When I'm running the program, nothing is coming on my command line or console. I have a printf in my program, but nothing is getting printed. What's happening here is that program execution has paused at this line, at this first scanf, and program is expecting user to type in and enter something in this command line or console for this scanf in the format passed to scanf as argument. In first argument to scanf, which is a string constant, as you can see, we have passed %d. So program is expecting user to type in only a number. Formatting rules for printf and scanf are same. Just the way printf prints things in a format, scanf reads data in a format. What I'll do here is I'll just type in an integer and I'll press enter, and nothing is getting printed even now. Now the program is expecting me to type in and enter something corresponding to the second scanf. Once again, it should only be a number. So I'll type in another number here, and now when I'm pressing enter, this is what I'm getting. Output of my printf is A equal 24, B equal 15, and A into B equal 360. So when the control has reached printf, value in A is 24, value in B is 15, and value in C is 360. What has happened here is that when we have entered the first number corresponding to the first scanf, this number has been filled in A, and when we have entered the second number corresponding to the second scanf, this number has been filled in B. So as we can see, scanf can be used to read input from program's command line or console. Corresponding to each %d in string constant passed to scanf, we must have another argument that should be a variable of type integer preceded by an ampersand, and the value read for this %d will be filled in this variable. Just like printf, we could have a scanf with multiple %d. In the format passed to scanf, we mostly do not put arbitrary characters. we mostly put these placeholders for variables. If you remember other placeholders from previous lesson, then we use %f for float data type that can be used to store a real number. We use %c for a character, and there are a lot more. We'll get to know them later. So in scanf corresponding to a %d, we must have an argument that should be name of an integer variable preceded by an ampersand. Corresponding to a %f, we would have to pass a variable of type float preceded by an ampersand. And similarly, corresponding to a %c, we would have to pass a character preceded by an ampersand. These placeholders are same for printf and scanf. In printf, you do not put an ampersand before the variable name, but in scanf, you put an ampersand before the variable name. Now, as I was saying, in format string passed to scanf, we would mostly have these placeholders and void spaces. It won't make much sense having characters not forming a placeholder. If I'll run this program as per the format passed to scanf, I should type in an integer, then a space, and then another integer. But a space in scanf, a space in format string of scanf, discards multiple contiguous void spaces. So what I can do is I can type a number of spaces here and then type in 15. And now if I'll press enter, then also A and B have been filled properly. So scanf is not strict about the single space in format string. It accepts multiple spaces against a single space in format string. Spaces and end of line characters, when you press enter and end of line character goes as input, these characters are treated as delimiters between values. Even if I would type in the first integer and then type in some end of line characters by pressing enter and then type in the second integer, then also A and B will be filled properly. A space in format string of scanf will actually accommodate all contiguous void spaces and end of line characters before the next value. You can write a scanf like this, but I prefer writing one scanf for each variable. So I'll revert back to two scanfs here. And now I want to do one more thing to make this program better. Before this first scanf, I want to write a printf saying enter A, and after the first scanf and before the second scanf, I want to write another printf saying enter B. Now let's run this program and see what happens. We are first printing enter A, and then we have paused for the user to enter the number. I'll type in a number here and press enter. And now we are first printing enter B, and then we are pausing for the user to enter second number. And once I'm pressing enter, I'm getting output of the third printf. This looks cool because now our program is printing a message and asking the user to input the numbers. Okay, now I want to answer a question that I had left earlier. Why are we having to put an ampersand before the variable name in call to scanf? To understand this ampersand, we will have to go into details of how memory is managed for execution of a program. A program will have multiple function calls. Program execution always begins with the main function. So the first function call that will be made automatically when the program will start will be a call to main function. And then any function can make calls to other functions. So here, as we can see, main function is making calls to these two library functions, printf and scanf. Now, when a function is called, some amount of memory is allocated specifically for execution of that particular function call. And this memory is reclaimed when the function call finishes. I have cleaned up everything from the memory. And now let's try to understand what I'm saying visually. When a function is called, some amount of memory is allocated specifically for execution of that particular function call. Let's say the program has just started execution, so main function has been called. Let's say this block in the memory is for execution of main function. Now a variable declared inside main function will get space inside this block of memory. We have three variables in main, A, B, and C. These three will live inside this memory allocated for main. A variable declared inside a function is called local variable, and we can access it and write to it from only within the function. When that variable is passed as argument to a function, like here in this last call to printf, we are passing a, b, and c as arguments, then all that happens is the values are copied to local variables in called functions. So printf will just receive the values in 3 local variables. Printf cannot modify a, b, c of main. Printf can modify its own copy if it wants to. Now with scanf, we want to fill in data in local variables of main. With the first call to scanf, we want to write to a of main. To do this, what we do is we pass the address of a to scanf. Every variable would have an address in memory, and address of a variable can be passed as argument. Let's say a is at byte address 200. Now when we are saying ampersand a here in the call to scanf, what we are doing is we are passing value 200, which is the address of a, and scanf is receiving it in a local variable. Now scanf has a reference to a. In C, a variable that stores address of other variable is called a pointer. So scanf has a pointer to a, and using this pointer it can access and modify value in a, and this is how scanf will be able to write something here. If you want to understand this in detail, you can check the description of this video for a link to our lesson on pointers. So in printf we are passing values in local copies, but in scanf we are passing address, so scanf can access the variable in main. If you are not able to understand some of these concepts that I just explained, then you can just let go. I'll explain these concepts in a lot more detail in later lessons. For now, you just need to understand how to make calls to printf and scanf, that is, how to read input and print output. Using printf and scanf, we are reading and writing through command line, console, or text window, whatever you call it. Scanf is receiving the typed in text from command line, and printf is displaying output on command line. Input and output can happen in multiple ways. In the beginning, we were filling data in code itself. We were setting values of a and b in code itself. You cannot expect normal user to make changes in code and then compile and run it. Only your programmer friend can do it, so that was not a good way. Next, we have used scanf and printf functions to read and write text from command line, and this looks cool. When we input using keyboard on command line, then this is referred to as reading from standard input, and when we write to command line, then it's called writing to standard output. Another way to input can be a file that our program can read, and program can also write back to a file. A modern day application can also take input from something like a scanner, and output can also be printed using a printer. Throughout our lessons, throughout this series, we're going to use standard input and output. We're going to use scanf and printf. We'll have a couple of lessons on reading and writing to file as well. Okay, in our previous lesson, we saw how we can read input and print output using scanf and printf, and we also wrote a basic program to find product of two numbers. Now in this lesson, we will see in detail how we can use various arithmetic operators to perform calculations in our program. Let's get started by writing some code. I have already written a couple of lines here. First line at the top, is a comment. A comment is ignored by the compiler. It's not treated as an instruction to be executed. To write a comment in a single line in C, we need to type in 2 forward slashes, and anything starting the forward slashes till the end of that line would be a comment. In the next line, I have written an instruction to include stdio.h library. This library gives us some basic functionalities. Printf and scanf are part of this library. And after that, I'm writing my main function. Now in my main function here, what I want to do is I want to declare 2 integer variables named a and b, and I want to ask the user to input these 2 integers. So I'm first printing a message on screen, enter a, and then I'm using scanf to receive input in a, and just like a, I'll receive another integer value in b. And now let's do some maths here. I first want to calculate sum of a and b, so I'll declare an integer variable named sum, and after I've got a and b as input, I'll say sum equal a plus b, and with this instruction I've calculated sum of values in a and b, and I've assigned it to this variable named sum. And now I want to write a printf to say a plus b equal whatever the sum is. Now next I want to calculate a minus b. I have declared a variable named diff, and I'm saying diff equal a minus b, and once again I'll write a printf. So this is my difference. Next I want to calculate the product of a and b. I'm multiplying a and b with this expression a asterisk b. Asterisk is the symbol for multiplication operator, and I'm storing the value in this variable named product. So with this much of code, we have asked the user to enter two numbers a and b, and then we are calculating and printing a plus b, a minus b, and a into b. Let's quickly run this program and see what will happen. The program is asking me to enter a. Let's say a is equal to 10. Now it's asking to enter b. Let's say b is equal to 5. And now we have got some output here. As we can see, output of all the three printfs has come on a single line. This is happening because printf by default does not take the cursor to the next line. We need to explicitly insert an end of line character to take the cursor to the next line. What I'll do here is, at the end of the string constants in each of these printfs, I'll type in backslash and then n. Backslash and n together is treated as a single character. Backslash n is called end of line character. For a backslash n, an end of line character will be printed and cursor will go to the next line. So I'll put backslash n in all three printfs. And now when I'm running this program, output of each printf is coming on a separate line. In the first printf, %d in the string constant will be replaced with value in sum, and that's why we have a plus b equal 15 printed here. 10 plus 5 is 15, and similarly a minus b, that would be 10 minus 5 is 5, and a into b is 50. End of line character, which is also called new line character or line break, should be interpreted more like a command to be executed rather than as data. It's inserted in data, but it works like a command. It takes all the text following it to a new line. Okay, so with this much of code, we are performing addition, subtraction, and multiplication. Let's now perform division. Let's say we want to divide a by b. If I'm dividing a by b, then a may not be completely divisible by b. B may not be a factor of a. In such a case, we can show the result, the outcome of division, in two ways. We can either show result as a real number. For example, if I'm dividing 9 by 2, then the result would be 4.5. There would be a fractional part. Or what we can do is we can say that quotient of this division is this and remainder is this. Quotient is basically the integral part of the result of a division. To perform division in my code here, I can use division operator. I'll declare a variable named c here, and I'll write a statement c equal a by b. / is my division operator. And now I'll print this value. I've written a printf a by b equal whatever is assigned to c after division. Let's quickly run this and see the output. This time I want to say a is equal to 9 and b is equal to 2. What I'm getting here is a by b equal 4. We are getting the quotient. This is happening because a and b both are of type integer. We have declared them as int. And when division operator is applied to two integers, then only the integral part or the quotient is returned back. If you want the fractional part as well, then you need to declare a and b as variables of type float or double. Float and double are types that are used to store and perform calculations on real numbers. What I'll do now is, in the declaration statement, I'll change this int to float. So now all my variables are of type float. Now in all the scanf and printf statements, the format string or the string constant should have placeholder %f instead of %d. %f is placeholder for float. Let's run this program now. Once again, I'll say a equal 9 and b equal to 2, and see what we have got here. Data is being printed with fractional part. By default, printf is printing 6 digits after the decimal point. We can choose to print as many as we want. Let's say I want to print only 2 digits after the decimal point. Then instead of writing %f in my string constant as placeholder, I'll write 0.2f, %.2f. And now only 2 most significant digits after the decimal point will be printed. If I want 3, I'll say 0.3f. Let's just put 0.2f everywhere in all the printfs. And let's run the program now. Once again, let's say a is equal to 9. And now, because we are scanning a floating point number, a real number, we can also enter something like 9.0. I can have a fractional part in my input as well. Now let's say b is equal to 2. It's not mandatory to enter the fractional part if it's 0, and this is what I'm getting. All the values are being printed till 2 digits after decimal point. There is another data type that can be used to store real numbers, and it's called double. So instead of using float here, we could use double. With double, you get twice the memory or storage as compared to float. In a typical architecture, size of float would be 4 bytes or 32 bits, and size of double would be 8 bytes or 64 bits. If my variables are of type double, then I need to use %lf as placeholder in these format strings passed to printf and scanf. Okay, now I want to come back to integers, and I want to talk about one more operator. And this operator is called modulus operator. As we had seen earlier, division with integer types gives us the quotient. I'll rename this variable c as quotient. And now I want to declare another variable named remainder. Modulus operator gives us the remainder. Symbol for modulus operator is this character, this %sign. With this statement, remainder equal a modulo b, we will get the remainder of division of a by b. I'll just print the remainder. Let's run this program and see what happens now. I'll say a is equal to 9 and b is equal to 2, and this is what I've got. In the last line, I have got 1. If I'll divide 9 by 2, remainder would be 1. I'm writing the value only. I'm not writing something like a modulo b equal this. Actually, let's just print this like all other lines. In this last printf now, I'm writing a %b equal %d. %d is my placeholder. Now when I'm running this program, I have not got the %sign here in the output of last printf. This is happening because % is treated as a special character by printf. It's treated as beginning of a placeholder. To print this character using printf, what we need to do is we need to put 2% together. If we will put 2% together, printf will not look at the pair in context of a placeholder. As you can see, now we have got the output a %b equal 1, or we should say a modulo b equal 1. Okay, so now we know how to do some basic arithmetic in C. We can write an arithmetic expression and assign it to a variable. Once the expression is evaluated, result will be stored in this variable. In this statement, sum equal a plus b, this equal to sign is for assignment operator. In right hand side of assignment operator, we have an arithmetic expression, and in left of this assignment operator we have a variable name. We cannot have anything else in left of an assignment operator. It must always be a variable. In right, we can have a constant, a variable, or an expression. Here we have an arithmetic expression, and we have a really simple arithmetic expression here. We could have a really complex one with multiple constants, variables, and operators. I have written some more instructions here, and in all these instructions we have arithmetic expression with more than one operator. We can write such complex arithmetic expressions, but we must understand how to create syntactically correct expressions in code, and we must also understand how these expressions will get evaluated. We have discussed these 5 arithmetic operators. All of these are binary operators, an operator that operates upon 2 operands is called a binary operator. Operand, by definition, is an object on which operation is being performed. For all these operators, we must have an operand in left and another operand in right, and the operator itself would be in between. Operand can be a constant, a variable, or in a complex expression, operand can be an expression itself. Let's pick this expression a plus 2 into b. We have two operators here. We have addition and we have multiplication. Now can you tell me the operands for each of these two operators? Well, it will depend upon which operation we are performing first. If we are performing the addition first, then for addition operands are a and 2, and for multiplication operands are a plus 2 and b. But if we are performing the multiplication first, then operands for multiplication would be 2 and b, and operands for addition would be a and this expression 2 into b. If you remember your high school mathematics, then precedence or priority of multiplication and division operations is higher than that of addition and subtraction, and so in this expression multiplication will be performed first. So this is correct interpretation and this is incorrect. In a complex expression, operator precedence is applied to decide the order of operations. In an arithmetic expression, first preference is given to parenthesis. Next in priority or preference are multiplication, division and modulo, and then come addition and subtraction. If there are two operators of same priority, then they are executed from left to right. By this expression a plus 2 into b, what we implicitly mean is a plus and then 2 into b within parentheses. If we want the addition to be performed first, then we must put parentheses explicitly. We should actually write expression like this. Now I have come back to this code that I had written earlier. What I'm doing here is that I'm assigning these expressions to variables. What we can also do is that we can pass these expressions directly as function arguments. So in the first printf, instead of passing sum, I can directly pass a plus b, so I don't need this variable named sum. And similarly in the next printf, I can simply pass a minus b. In the next I can pass a into b. For the quotient I can pass a by b, and for modulus we can pass a modulo b. If you'll run this program, you'll get the same output as earlier. So an arithmetic expression can be assigned to a variable, or it can be passed directly as argument to a function. Okay, now what I want to do next is I want to erase all the code in this main function, and now I want to write some arithmetic expressions and I want you to guess the output. What do you think will be the output of this program? Give this some time and deduce the answer. In this expression a plus b by 2, we have two operators, addition and division, and we have no parentheses, so division will be performed first. b is 3 and 3 by 2 will give us 1. Remember, when we divide an integer by another, we get the quotient or the integral part. So b by 2 would be 1 and a is 4, so c would be 4 plus 1, that is 5. When I'm running the program, as you can see, I've got 5. Now what should be the output of this one? We have two operators, subtraction and addition. They have equal priority, so they will be executed from left to right. a minus b would be 4 minus 3, that is 1, and c is 6, so 1 plus 6 would be 7. d would be 7. Okay, now what should be the output of this one? Part of the expression within parentheses will be executed first. a plus b would be 7, c minus d would be 1. So e would be 7 into 1, that is 7. And my guess is right again. So with this much, I hope you got some understanding of how you can perform arithmetic operations in your code.